Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Mastering Data Structures and Algorithms in Java coding series. Today's video is on data structure linked list. This is the part 2 of linked list. In part 1 we have already covered the theory and fundamentals of linked list, how a linked list is formed, how is it different from array, and the internal details of linked list and how linked list is a fundamental data structure. So in this video, we are going to cover few of the code examples on linked list. Majorly, we'll be covering on singly linked list, doubly linked list, and circular linked list. Okay. So let's start with the singly linked list. We'll do a quick revision. We have to implement a linked list with operations insert, search, delete, and display. Okay. So let's start with a linked list here. We have the linked list 1, 2, 3. 4. This is what we have to form. So you do know that we create a linked list like this. This will be 1. It points to 2. It will point to 3. And then to 4. And the next of 4 is null. Plus, for creating a linked list, there are two important things. One is you have to create a list node. So we'll create a list node where we save the data, so we can have int value, and then similarly we'll have list node next, that is this pointer. Okay, so this place is for value and this place is for the pointer which is named as next, and then we'll have the constructor list node int value. So whenever we initialize, we'll say this dot value is equal to value, and this dot next is equal to null. Okay, so whenever we'll create a list node, a complete list node will be created, one node will be created. So let's say we create a list node of type 1 of value 1, and its next will point to null, right? So similarly, we are going to perform different operations on this. So one by one, we'll look at the operations and we'll come back to this understanding as well. So let's start. Okay, what do we need? Let's create a class. First, let's create a list node. Okay, so list node. As discussed, we need two things. One is value, and then list node next, the pointer of list node type, then the constructor list node int value, this dot value is equal to value, and this dot next is equal to null. Okay, so we have created a class of type list node. So with this we have actually created our list node. Okay, now let's start with linked list. So we'll create another class. Let's name it singly linked list. Okay, what do we need in the beginning? We need our main method, public static void main string args. Let's see if it is working fine. Out.println personal advertisement and 45 engineering. Let's run it. Okay, as of now it is working fine. Okay, so what do we need to do? We need to create an element, not element but the object of our singly linked list first, right? We can call it anything. We'll say singly linked list is equal to new singly linked list. That's all. So now we have a list. Now what we need to use our list node to create the head and other elements. So let's create private list node head. We created head. Now this is not pointing anywhere, this is not doing anything as of now. Okay, we have just created a variable of type list node as head inside a singly linked list. Okay, now let's create a constructor for this. So generally we have the default constructor, but we'll create one. So public singly linked list, so that when we are creating the object as we have created in line number 8, it will initialize our head with null. Okay, so when we create a singly linked list, a head is created that is of type list node. It does not have any value and it points to null, so that it is basically null. Okay, now one by one we are going to perform all our operations. So what are the operations that we need to perform? We need to perform insert, search, delete and display. Okay, so let's insert at the end of the linked list or at the end of the list. Okay, so for insert we'll say public void insert. We need the value, so int value. Okay, int value. Okay, so now when we are performing the insert operation, I want you to pay close attention to this. Let's remove these parts for now. This list node is clear to us, so we'll remove. Okay, so when we want to create this list, okay, this complete linked list, first we have to create a node and then assign the value and the null to it, right? So we'll come back to this part. So let's do it. In the insert operation, what we are doing is we are creating a node first. So list node, we'll call new node is equal to new list node, and we'll pass the value, that is value. Okay, now let's say in the value we have passed list dot insert and we pass 1. Okay, so with this line what will happen? A new node is created of type list node. As we have seen, list node has int and next pointer, right? So a new node is created, but as of now that's all we have done. So a new node will be created here and then it is of value 1. So what happens is the moment we create a list node, it is initialized with the value and its next pointer is initialized with null, right? So its next pointer will be null. Okay, let's go back to singly linked list. Now one by one we want to insert the value. As of now we have created the new node. Okay, now we'll check if our head is equal to null. So that is true in this case as of now, because our head is null. This node is separate, it is not attached to our head. Okay, only a node is created. So if our head is equal to null, we'll say head is equal to new node. Okay, so this is the node this is the new node that we have created. Earlier we have created a head that was null. Now we are saying head is equal to new node. So head is pointing here. So now this will become like that we have created a new node, that is 1. Its next is null and head points to new node. Okay, we want to create this. In the end, head is going to be here. Now we have the head, we have the value 1, and then the next of it is null as of now. Okay, now else. Okay, when we have already inserted 1, but now we are getting a new node. Okay, so we wanted to insert 1 is inserted, but now I'm saying list dot insert 2, then list dot insert 3, then list dot insert 4, right? So one by one we are inserting all the elements. So when the first value was there, 1 was there, we created a new node, head was null, so we pointed the head to the new node. Now when we are inserting another node, value 2 in line number 20, So we'll say int value list node new node. So a new node will be formed. So a new node will be formed. Let's say a new node is formed here. Okay. Of value 2. So again the same thing will happen. It will have 2. Its next pointer will be initialized to null. Right. Now we are saying if head equal to null. No, right? Because now the head points to new node. So we'll come to the else part while inserting the value 2. Now we'll check, we'll create a temp node like we discussed yesterday. List node temp is equal to head. Now we'll traverse to the end of the current linked list, and in the end we are going to insert our new number. So we'll say while temp dot next is not equal to null, temp is equal to temp dot next. Okay, and then temp dot next is equal to new node. Okay, so please pay close attention. We first created a temp node. Okay, we first created a temp node. So a temp node is created and we pointed to head in line number 14. As you can see, temp node is equal to head. So temp node is now pointing to head. Now we check while temp dot next is not equal to null. Okay, now we see temp is pointing to head, so temp dot next is null, right? It is already null. So we do not enter the while loop, we come out, we say temp dot next is equal to new node. Now temp dot next is this, because this is head dot next plus this is temp dot next as well. Wait, why is it not typing? Plus it is head dot next and it is temp dot next as well. But now we are saying temp dot next, we said temp dot next is equal to new node, and this is our new node currently. So this will get replaced and temp dot next will point to new node, right? So we have now inserted 2 at the end of 1. Similarly, again the same thing will happen. We'll create another node. Node 3 will be created and it will have null. We'll traverse the loop again. We'll say temp is equal to head while temp dot next is not equal to null. So now loop will enter here. Temp dot next is not equal to null. Temp is equal to temp dot next. So we'll keep traversing via temp to the next until temp dot next is not equal to null. So earlier we were till 1, now we are till 2. Once we found out that temp dot next is equal to 1 is equal to null, while loop will break here. Temp dot next is not equal to null, so the we'll keep moving temp equal to temp dot next, and the moment temp dot next is equal to null, while loop will break and we'll say temp dot next is equal to new node. So in this case temp dot next, temp is pointing to here now, temp dot next is null, so we'll replace temp dot next is equal to new node. Now this one was new node, so temp dot next will now point to the new node, right? Again when 4 comes, so we go back here, list dot insert 4. Okay, so what do? List node new node. So a new node is created for 4, so a new node will get created for 4. It will be initialized with the value, its next pointer will be null, right? We'll say if head is equal to null. No, head is not equal to null, right? Because head is pointing to 1, so head is not null. Now else list node temp is equal to head. So again we'll have a temp, so let's remove this. We'll have a temp and temp will point to head, that is this one. We'll say while temp dot next is not equal to null, temp is equal to temp dot next. So we'll keep the traversal on. So temp dot next is not null, so temp is equal to temp dot next, we move here. Temp dot next is not null, so temp is equal to temp dot next, we move here. Temp dot next is not null, no, temp dot next is null, right? So the while loop breaks, we come out of the while loop, we say temp dot next is equal to new node. Now here this was a new node now, so temp dot next will now point to new node. So in the end, if you see, we have created this complete linked list. We have the head here, we have 1 2 3 4, end of 4 is null, 1 is pointing to 2, 2 is 3, and 3 is pointing to 4. Okay, I hope this was clear. Right, now let's look at the other operation that we have to perform. What is the other operation? We have to perform search. So we'll search an element, right? Now for searching, okay, let's write the code for searching. Okay, we'll say search for a value in the list. With linked list, the only possibility for us to search is going one by one. So we start from the we start from the head, we search here, it matches the value, it doesn't match the value, we go next, we go next, we go next, until either we have reached the null or we have found the value. That is how we do the search operation here. Now, what do we want? So, okay, one thing before actually going through all of this, let's do one thing. We have our linked list here. Let's run it for a while. Okay, let's write a code for displaying the linked list first, so we can at least see our linked list, right? Display the list. Okay, so after we can remove, no, okay, we'll take this from here. Okay, now once we have created the list, we'll display the list. So we'll say list dot we do not have a method for display, we'll just call it display. Okay, and then now we'll display the element here, display the list. So we'll create a display method, public void display. How will we display? One by one we have to traverse through the list and print them out. So we create a list node, temp, point it to the head as discussed, and then we'll keep moving. So while temp is not equal to null, we'll print the value system.out.print, and we'll say temp dot value, right, plus, let's give some space. Okay, and then move the pointer, temp is equal to temp dot next, right? Of course, after this we'll print one extra line, system.out.println. Okay, now if you see, what we are trying to do here is we have this operation temp to display. We initialize a new node. Let's remove these things. We don't need this, we don't need this. Okay, we don't need this. Okay, now we create a new node, temp of type list node, right, as we can see, of type list node, and then initialize it to head. So temp is initialized to head, so temp is pointing here. We check, is temp not equal to null? That is correct, right? Temp is not null, so we'll print the value, temp dot value. So this is value, right? This first box is value, the next box is next, that is pointer. So we'll print the value, temp dot value will be equal to 1. Once we have printed the value, we'll say temp is equal to temp dot next. So now temp will move to next, that is 2, because temp dot next is this, and this is pointing to 2, temp will come here. Then again new temp dot value is equal to 2, then temp is equal to temp dot next, next is this which is pointing to 3, so temp will come to 3, and then we'll print 3 and 4, right? So let's just quickly run it. Run 1 2 3 4, right? We are able to print our list. Now let's do one thing. Okay, let's write a method to search an element in the list. Okay, public void search int value. Now we are going to print whether this element is available in the list or not. So we'll say system.out.println and we'll say is 3 present. Okay, we'll give space and we'll say list dot search and we'll pass the value 3, right? What am I missing? Okay, since we just want to return true or false, we'll have to give the type as boolean. Okay, now we want to search if an element 3, if the element if the value 3 exists in the list or not, right? We already know that 3 exists, but this is to teach all the basic operations. So we did the insert, we did the display, now we are going to search the element. 3 exists in the list, we know, but how we are going to search it, it will be very same to how we did the display part, right? So we'll say again just like display, so I'll pull the code for display also so you can see, right? We'll say list node temp is equal to head, same, right? Now we are going to check while temp is not because we have to traverse our list, our linked list, right? While temp is not equal to null, so we can move one by one. Now we'll check the value. If temp dot value is equal to value, that is this value, we are comparing this value with the linked list value, that is temp dot value, as we can see here. So this temp dot value, each time when we do a temp dot value, it fetches the value from the node. When we move the temp to next, again temp dot value will fetch the value, right? So let's go back. We are saying if temp dot value is equal to value, that means we have found the element, so we can simply return true. But if it if it is not there, so if this statement is not true, we'll move to the next node, temp is equal to temp dot next. But if after the end of the complete list, because this will the loop will break once temp has reached null, if we have reached null and we did not find the element, that means the element does not exist, so we can simply say return false. Okay, let's do a quick run and we can say is 3 present, true, right? Let's say we want to check if 6 is present and let's run it. Is 6 present? False, it is not present, right? Okay, I'll switch it back to 3 just for understanding. Now is 3 present? Yes, 3 is present, right? Similarly, now imagine that we have to delete a node. Okay, so we'll say delete a node from the list, but how do we want to delete it? Okay, we'll delete it with the value. Okay, so we'll say public void delete, we'll pass the value int value. Okay, now before I go on and write the code, let's go to our linked list here. Okay, we have the list like this. We have 1 pointing to 2 pointing to 3 pointing to 4, right? Now we want to delete an element and let's say we want to delete 3. So we'll pass the value that we want to delete 3. How can we delete 3? Now before I go on and code this, just imagine how can we actually delete 3? What do we need to delete this element? Just take a minute here and think of an approach that you would take to delete the element. It is very simple, same as doing the traversal as we did for search or display. But now when we want to delete an element from 3, all we can do is we can directly point the previous node directly to the next node, and then this connection will be lost and after 1 we'll get 2, and then after 2 we'll get 4. So 3 will be lost for us, right? So this way 3 is deleted. And how it actually gets deleted is we only remove the link, and once the link is removed, this gets garbage collected in the end. So we change the next pointer of 2 directly to point to 4. But how can we change the next pointer of 2? That means while we are traversing from 1 to 2 to 3, we should keep count of the previous node. So we would need another pointer previous. For doubly linked list it would have been much easier, but for singly linked list we'll keep a pointer for the previous node, and we'll check whenever we reach the value 3, we'll directly use the previous node and say previous dot next is equal to this node, let's call it current, sorry, this node, let's call it current node when we are at 3. So we'll say previous dot next is equal to current dot next. So previous is this, previous dot next will point to current dot next. Current dot next points to 4, so previous dot next will point to 4, and then this will get deleted, right? So let's just do it in the code. Okay, so we want to delete. First thing we'll do a check if head is equal to null. That means if head is equal to null, that means it's a blank list. We don't have to do anything, so we can simply return from it. Otherwise we'll say if, what if the head node is the node that we want to delete, right? So it's a edge case conditions. So this was one edge case condition, that what if the list is null. Other edge case condition is what if the head, we have to delete the head only, so we don't need to traverse, right? So we'll check if head dot value is equal to the value. That means we can simply just point head to its next pointer. So we'll say head is equal to head dot next, and we'll simply return from here. But if both of these is not the condition, now we'll have to traverse. So we'll create pointers. First let's create list node, let's call it previous is equal to head, and then list node, let's call it current. This is, we could call it temp as well, and we'll point it to head dot next. Now why current is pointed to head dot next? Because we have already checked the head node in this one, right? So now what we are doing is, we have this list, let's do it quickly again here. Okay, so we have this list 1 2 3 4. Okay, this is the one that we want to delete. Okay, so we have created 2 nodes. So head right now is pointing to the start. We already checked that the head dot value does not coincide with the value 3, so we'll initialize 2 pointers. Previous will point to head, and current, or as we have named it current, will point to head dot next. So current is pointing to 2. Now we'll do the comparison directly for the current pointer. If it is not equal to null, we'll check for the value. If the value matches, then we'll simply point previous dot next is equal to current dot next. If it does not matches, we'll simply move both the pointers. Current dot next will move to next, and previous dot next will move to current. Okay, so we can do current is equal to current dot next, and previous is equal to previous dot next, or simply we can do previous is equal to current and current is equal to current dot next. Anything is fine. Okay, but we are going to move both the pointers if we do not find the coinciding value. So what will happen is, we'll check for the current dot value is equal to the value that we received 3. No, so it is not equal, right? So we'll say previous is equal to current. So previous will then point to current, that is 2, and we'll say current is equal to current dot next. So current will point to current dot next, this is next, this is pointing to 3, so current will move here. Now previous is pointing to 2, current is pointing to 3. Again we'll check current dot value is equal to value 3. Yes, that is the value. When the loop is true, then we'll simply say previous dot next, that is 2 dot next is equal to current dot next. So previous dot next will point to current dot next. Okay, let's look at it in the code. Where are we? Okay, so we have created this. Now we'll check while current is not equal to null. So we'll say if current dot value is equal to the value that we have received, that is this value. Okay, this is current dot value, this is the value that we are receiving. If current dot value is equal to value, that means previous dot next is equal to current dot next. So simply current node will be deleted, and then we can simply return from here. But if this is not the case, like when we are at 2, so this is not the case, we'll move both the pointers. So previous is equal to current, so previous will now point to current, and current will now point to current dot next. Okay, this one we could have also written it as previous dot next, right? Because previous dot next would be pointing to current only, or we can write it as current. Okay, so this is how we are going to delete the element. So let's delete one element. We can say list dot delete. Let's delete 3, and then after deleting, let's display it again. List dot display. Okay, let's run. So you can see in the first display we are printing the value 1 2 3 4. Then is 3 present? Yes, 3 is present. Then we deleted 3, so now 3 is deleted. We printed the list again. Now it's 1 2 4. Okay, I hope this was clear. We covered the major operations. We did the insert, we did the search, we did the delete, we did the display, and this is how you form a linked list. Okay, so remember, one is that we need a list node like this one. There will be a node where we save the value and pointer for the next, and then we have the linked list, and you have the operations. One is insert. We are inserting at the end of the linked list. Similarly, you can insert in the beginning also, and you can just move the new node. We have the search. This is just traversal. We use the same traversal for display also, and if you see, delete is also a modified traversal only, because here also we move both the pointers, right? But this is how we traverse. We check for null. If it is not equal to null, we move the temp to temp dot next, as long as we don't reach the last value or we don't find the value that we are looking for. Or as in case of display, we move one by one. Temp is not equal to null, we print the value. Temp is equal to temp dot next. Again, it's not null, print the value, move to next, right? So I hope this was clear. Now this was for the singly linked list. Now let's say for doubly linked list, we'll do a quick check for the palindrome. So palindromes are like 1 2 3 2 1. If you read them from front, it is 1 2 3 2 1. If you read it from back, it is 1 2 3 2 1, right? So this is what we are going to perform for a doubly linked list. So let's start with a doubly linked list. We'll create a list node again. We'll create another list node. Okay, so we'll call it list node, list node for double, so list node D. Okay, because now we'll have, what do we have in a doubly linked list? Let's quickly go here. Okay, in doubly linked list, as we discussed, we have doubly linked list looks like this, right? So it has previous pointer, value, and next pointer. So if we create doubly linked list for 1 2 3, it will look something like this. Right? 1 2 3. 1 dot next would point to 2, 2 dot previous will point to 1, 2 dot next will point to 3, 3 dot previous will point to 2, 1 dot previous will be null, 3 dot next would be null. Okay, and we'll have a head node that will point to the start, and similarly we can have a tail node that will point to the end. This is what a doubly linked list looks like. Okay, so let's jump to the problem. So we'll create a doubly linked list. We have int value, we have list node previous, we have list node next, then we'll have the constructor list node int value, this dot value is equal to value, this dot previous is equal to null, this dot next is equal to null. Okay, so in the beginning the previous and list node d. So in the beginning previous and next both pointers will be null and only value will be initialized, right? Now let's create a class. We'll call it doubly linked list. Okay, let's create our main method, public static void main, oops, typo, public static void main, string args. Let's see if the code is working fine. System.out.println 1045 engineering, right? Let's run. Okay, it's printing 1045 engineering. Okay, now similarly how we did for doubly linked list, we are going to how we did for singly linked list, we are going to do for doubly linked list also. Okay, a few of the things that we would need is we'll have the nodes. So we'll say private list node d, we'll call it head, and then similarly private list node d tail. We'll create the constructor public doubly linked list, this dot head is equal to null. This is similar to how we did for singly linked list, right? This dot singly linked list only had head, now we have head and tail. Okay, this dot head is equal to null, this dot tail is equal to null. This is for creating the constructor. Like here when we will be doing this doubly linked list is equal to new doubly linked list, we'll get the head and tail initialized to null, right? Now we'll create our insert method, insert at the end of the list like we did previously. So we'll say public void insert int value. This code is very similar to the one that we just covered, so I'll just move fast. We'll say list node new node is equal to new, oops, we have to call it list node d, it's doubly linked list, new node is equal to new list node d, will pass the value. Okay, so what will happen is new node is created, so we'll be sending the value let's say we'll be for the palindrome we'll be sending the value 1 2 3 2 1. So first value that we have sent is 1, so a list node is created of doubly linked list type, it gets the value 1, its next is null, its previous is null, this is value, this is next, and this is previous, right? Okay, so list node new node list node d value we get. I will check if head is equal to null, that is true for the first case, so we can directly point the head to the new node, so head will point to new node, right? Similarly else if head is not equal to null, so we'll check for tail dot next is equal to new node. Okay, now when we were why there is an error, tail node, where did we create tail node is of type t, new node is of type t, tail node dot next required type was list node and the priority type is list node d. Why? Where is the required type list node? Nowhere we have used the list node. I think we are getting a small error somewhere. We have to find the imposter here. So we have the list node D, new node value for head and tail, both are list node D. Somewhere we are doing something wrong. So tail, where is tail? Tail is here, tail is pointing to null, tail is of type list node D. Okay, let's come back to this when it fails. Okay, and then new node dot previous is equal to tail. Okay. Okay, this is kind of bothering me now, and in the end tail will move to new node. Okay, it change field next type to list node D. Okay, I see where we did the problem. We'll go to list node D, and this was supposed to be list node D and list node D, right? Oh, because of similar name, this confusion. Okay. So one quick thing, if you notice, now what's happening is when we are creating a new node, we initialize the head here, we initialize the tail here. When we insert another new node, that is 2. For singly linked list, we used to travel one by one to find the last node and then insert in the end. But now we already have a tail, right? Every time we have a tail pointer that points to the end of the linked list. So we directly connect this earlier end to the new node. Right now it's null when a 2 is created. But what do we do? If head is equal to null? No, because 1 was already created. Let's say after 1 we get the value 2. So we come to else. Tail.next is equal to new node. So this is where tail is pointing. So tail.next, this is next, is equal to new node. So this will get removed. So tail.next will point to new node. Right? Then tail.next is equal to new node. New node.previous is equal to tail. Now earlier new node.previous is equal to null. So this will get changed. And new node.previous will point to tail. Tail was pointing here, so now 1 is connected to 2. But now tail is still here, right? We'll need to move the tail to the end also. So we say tail is equal to new node. So now tail will point to the new node, that is this one. So if you see, we had 1, head is there, it's null. Now it's pointing to 2 and tail is here. When we want to insert 3, a new node will be created, 3, like this. It will have both previous and next is equal to null. Then we'll point the tail dot next to the new node, because this would be the new node that time. Tail dot next would point to new node, so this one will get removed. Tail dot next will point to new node. Now new node dot previous will point to tail, so new node dot previous will point to tail. In the end, tail is equal to new node, so tail will point to new node. So you can say tail will be pointing to the new node here, right? Okay. So this way we have inserted the values. Now this was similar to singly linked list. The only benefit we have is now, since it's a doubly linked list, we can directly insert the elements in the end or in the front, because we have next and previous pointers. Okay, so let's insert the values. So we have the list. We'll say list dot insert 1, list dot insert 2, list dot insert 3, list dot insert 2 again. We want to create a palindrome. List dot insert 1, right? Let's display the list dot display. Okay, we do not have the display method. Let's create the display method. So display the list. So we'll call public void, and since we have a tail and head, we can actually display it from either side, from the head side also, for the tail side also. Since this is palindrome, it will print the same, but we can always do that. So list node temp is equal to head. We could have directly pointed to sorry, this will be list node d. We could directly point it to the tail as well, right? List node temp is equal to head. We'll do the same check while temp is not equal to null, right? We'll say system dot out dot println, not ln, we'll remove the ln, that is for next line, and we'll say temp dot value, right, plus some space. And in the end, not in the end, once we have printed this value, we'll move temp to temp is equal to temp dot next, and next line for the end, system dot out dot println. Okay, let's run the code. Okay, we have 1 2 3 2 1. Okay, now we want to detect if this is a palindrome or not. We know that it is in palindrome, but we have chosen this problem for doubly linked list because we can do the traversal from both ends, right? So let's do it. System dot out dot println is list palindrome. Okay, we'll create question mark. Okay, plus we'll call list dot, we'll create a method is palindrome. We have not created the method, that's why it is showing like an error exists here. So we'll create the palindrome. We have the display insert, let's create here. Okay, check if the list is a palindrome. Okay, so we'll say public boolean is palindrome. Now, okay, before going forward, let's just, okay, now we have the list to be created for 1 2 3 2 1. So it looks something like this: 1 2 3 2 1. Okay, head points here, the previous is null, the last one is null, tail points here, 1 2 3 2 1. 1 next points to 2, 2 previous points to 1, 2 next points to 3, 3 previous points to 2, 3 next points to 2, 3 previous points to 2 next points to 1, 1 previous points to 2. Okay, these are separate nodes. This 2 and 2, these are same values, but they are separate nodes, right? So we have 1 2 3 4 5 nodes in the list. Okay, now when we want to detect if there is a palindrome or not, what we can do is, since we have tail also and we have the head also, we can start the traversal from both sides. We'll start traversing from this side as well as from this side. We can compare the value. If let's say the head dot value, or will initialize a variable, let's call it front, that is initialized to this one. Let's call another pointer as back, that is initialized here. If we can check if front dot value is not equal to back dot value, return false. Otherwise, front will move to front dot next, back will move to back dot previous. So we'll have something like front is equal to front dot next and back is equal to back dot previous. Now back will point here, front will point here. Again we'll check, is front dot value not equal to back dot value, but they are equal, so it will not enter this. Again front will move to next, back will move to next. But then at one point in time they have reached the same values, right? Either they will reach the same value, or if we had something like 1 2 3 3 2 1, front will be at 3, back will be at 2. So this should be our breaking condition. Okay, this we can directly check if front is not equal to back or front dot next is not equal to back. So in this case we can check if front, while in the while loop that we run, while front is not equal to back, in this case front equals back, we come out of the loop. For the even number we could check while front is not equal to back, like this, front is not equal to back, or front dot next is not equal to back, right? Because in this case front dot next is equal to back. So we can break the loop here. And if in all of this we never entered this loop, that means this is a palindrome, and in the end of the code we can simply return true. Okay, so let's code it. Now is palindrome. First we'll do the basic check. If head is equal to null, or head dot next is equal to null. Head is equal to null means there's no node, so yes, it's palindrome. Head dot next is equal to null, that means there's only one node, then again one node is also a palindrome. So for both the cases we'll return true. Otherwise we'll create two pointers, list node D front is equal to head, and then list node D back is equal to tail, right? Now we'll check the breaking condition as we discussed. While front is not equal to back, or and both the conditions should be false, and front dot next is not equal to back. So if either of these condition is true, the while loop will break. So for odd numbers this one will break, for even numbers this one will break. Where is this one ending? Okay, wait, what is it saying? Missing return statement. Yeah, we'll come to it. Okay, now we'll check if front dot value is not equal to back dot value. If the values are not equal, we can return false. Like if let's say for some reason this value here was 4, right? So front is pointing to this side, back is pointing to this one. The values are equal, so front will move to front dot next, back will move to back dot previous. We'll again check if front dot value is not equal to back dot value, and this will be true because front dot value is 2 and back dot value will be 4. So front dot value is not equal to back dot value, so we will return false, that no, it is not a palindrome. So that is not the case here. In this case this is equal, and we are going to return true in the end, right? So if the values are not equal, we'll return false. Otherwise we'll move both the pointers, so front will move to next, front dot next, and back will move backwards, back will be equal to back dot previous. In the end, if we didn't find a false statements, we'll return true, it is palindrome. Let's run it. Is list a palindrome? True, it is a palindrome. Let me capitalize this, not capitalize, let me write this in capital. Oops, I did something. Run. I don't want to debug, I just want to run. Yes, is list a palindrome? True. Okay, so this problem we chose for doubly linked list to understand the code example on doubly linked list. Okay, I hope singly linked list is clear, doubly linked list is clear, and let's cover one code example on circular linked list or cyclic linked list. Now before going to circular linked list, please understand circular linked list is also like a linked list. It can be a doubly linked list or a singly linked list. It's just that loop exists in the circular linked list. Okay, So we have to detect if a loop exists or not, and then we have to return whether the loop exists, true or false. Okay, so let's just quickly let's just first understand. Okay, uh, okay, so what should be the example? Let's say okay, let's say we have 1 2 3 4. Okay, and consider singly linked list. 1 points to 2 points to 3 points to 4, and then 4 points back to 2, right? We discussed this example in the other in the part 1 video also in theory. And how do we detect if there is a cycle? If you see, there is no null, right? If you traverse this loop, you will start from one end, that is head. You will initialize somewhere temp is equal to head, and then you'll write your code while temp is not equal to null, temp is equal to temp dot next, then other pieces of code, right? So what will happen is temp will point to here, temp is not equal to null, so temp is equal to temp dot next will move to 2, then we'll move to 3, then we'll move to 4. From 4 we'll move back to 2 because the 4 dot next is pointing to 2. From 2 to 3, 3 to 4, 4 to 2, 2 to 3, 3 to 4, 4 to 2, 2 to 3, 3 to 4, 4 to 2, and so on and on. Okay, that means there is a cycle. Now in order to detect this cycle, we discussed that we keep two pointers, fast pointer and slow pointer. I'll not discuss this theoretically again completely because we have already covered this in very detail in the part 1. Please watch the part 1. We'll cover the code example here. Okay, so we'll use the fast pointer approach and the slow pointer approach, where slow pointer moves by one step, like temp is equal to slow is equal to slow dot next, and fast moves by 2 steps. Fast would be equal to fast dot next, right? And whenever they reach the same block, that is if the cycle exists, there will be a one point in time where fast and slow pointer both will be pointing to the same node. And if when this happens, fast is equal to slow, that means cycle exists. Okay, so let's start coding. We'll create another node. Okay, we'll go really fast on this one. List node, let's call it C for circular. Okay, we'll have int value, we'll have list node C next, then list node C int value, this dot value is equal to value, this dot next is equal to next, right? We have created a list node C. What's the issue? Oh, sorry, list dot next is equal to null. Okay, let's create our class. We'll call it circular linked list. Okay, let's create the main method, public static void main. Oops, static void main string args. Okay, system dot out dot println ten 45. Oops, what's happening? Let's run. Okay, the code is working fine, it's running and everything is okay. So now let's create a variable private of list node C. We'll call it head. We'll create a constructor, public circular linked list. Okay, and this dot, we could directly call it head also, but this dot head is equal to null. Okay, What else do we need? Okay, we need circular linked list is equal to new circular linked list. Okay, now when we are doing this, move. So as of now we have not created anything. Okay, so we are only thinking like we'll create one single linked list, we'll insert the elements one by one, we'll try to create a loop in the linked list, and then we'll try to detect it. Okay, ठीक है. Let's go like this. Let's follow the same approach. For the list we can say list dot insert, we'll insert one, list dot insert, we do not have the insert method yet, we'll write the insert method, so no worries. List dot insert 3, list dot insert 4, then we'll display the list, so we'll say list dot display, and then we'll create a loop, list dot create loop, we'll create loop on value 1. Okay, we'll create the loop on 1, that would be, or we can create it on any index, we'll pass the value that time. Okay, and in the end we'll check system.out.println does list have a loop, and we'll detect is using list dot has loop, we'll create this method. Okay, now these are the methods that we have to create. Let's start with the display first, so we'll say public, or let's put comments, display the list, public void display, same as we have been doing so far. If head is equal to null, simply return, we don't have to print anything. Otherwise, list node C temp is equal to head, point it to head, and then we'll say while temp is not equal to null, system.out.print will print the value temp.value plus space, and then temp is equal to temp.next. Okay, that will work for our display method. Only thing needed is we have to insert, and we have to detect if our loop is there or not. Okay, so we'll do one thing, display here, display method. Okay, we'll create insert at the end of the list. Okay, so public void insert int value. Now again, as we had discussed, list node, new node, this is exactly same as the singly linked list. Okay, the code. So I'm not going to go to the sketchboard and then discuss the same thing for this one, plus we have covered this very well in our part 1 theory as well. So list node new node is equal to new list node. Okay, something went wrong. Okay, this is C. Okay, okay, list node new node, list is new list node. We'll check if head is equal to null, because if that is the case, we insert in the beginning, so we'll directly say head is equal to new node, right? And then head dot next is equal to head. Okay, head dot next is equal to head. Why can we, let's make it circular as of now, make it let's not do it this way. Okay, head is pointing to the new node. uh, else will say list node temp is equal to head. Oops, it is C. List node C temp is equal to head. Okay, we'll say while temp dot next is not equal to null, we'll assign temp is equal to temp dot next, so that we can reach the end. Once we have reached the end, we can say temp dot next is equal to new node. This is how we insert at the end of the linked list in simply linked list. For doubly linked list, we could always directly use the tail, right? New node dot next is equal to head. Now new node dot next is equal to null. Let's make it circular from the beginning. Okay, I don't know. Maybe we'll make it circular from the beginning. Let's not make it circular from the beginning. Okay, so what do we have? We have a new node. We have head equal to new node. If no, then whenever each time we are inserting, we go to temp is equal to next. In the end, temp is equal to temp dot next. In the end, temp dot next is equal to new node, and of course new node dot next would be null, as we can see in list node C, right? Now apart from this, we need to create a loop. So let's create a loop. What's the name? Create loop. Okay, let's create a loop in the list. Public void create loop, int value, whatever value that we receive for, or let's call it index, whatever the index is that we receive for, so that we will go to that index and then do it. So we'll say list node temp is equal to head. We'll create a count. So this we are just creating a pointer, okay, before creating a loop in the linked list, before actually solving the problem to find out if a circular or if it is a circular linked list. That means if a loop exists or not. So before that we are just creating a loop. So we'll keep a counter, int count is equal to 0. So we'll go to this index and then create a circular ring after that. So we can say list node C. Oh, this should have been of type C as well. List node C temp is equal to head, list node C loop start. So loop will start at null. Okay, we have the null node or the loop start node. Now while temp dot next is not equal to null, so we start the traversal. If count is equal to index, so in index we are already getting the value. For count, we'll increase the count with each node. Okay, loop start is equal to temp if the count is equal to the index. So loop will directly start from the temp. Okay, and otherwise we'll say temp is equal to temp dot next and count plus plus, and what else, temp dot next is equal to loop start. Okay, so what's the value we are passing? 1. This way we'll create a loop where 2, because we are using the index 1 when we are starting with 0. So first one is 0, second one is 1, and on the second index we'll have the value 2. So a loop will be created. Loop will be created where 2 points back to 1. Okay, so we'll have something like this created. We'll have 1, 2, 3, 4, and then we are saying we are changing this 2 to point back to 1. Okay, we can do it for any index and then point back to the start. Okay, so the point is not to create the loop, but the point is to detect the loop. Once we have created the loop, we need to detect if the loop exists or not. Now the main code is actually to if we can detect the loop. Okay, so not here, we'll say detect loop in the list. Okay, so as discussed, we'll use the slow pointer fast pointer approach. Public boolean is loop wait has loop. Okay, public boolean has loop, and we'll now check if head is equal to null or head dot next is equal to null. So if there are 0 nodes or if there is only one node, we can return false, because then a loop is not possible. Otherwise, list node c slow is equal to head, list node c fast is equal to head. Both the pointers slow and fast are pointed to head, and we'll check while. Now just to understand, though we have discussed this in the theory video, but we are discussing this one more time here. Let's remove this part quickly. Okay, when we have something like this, 1 pointing to 2 pointing to 3, pointing to 4, and then let's say 4 pointing back to 2, and we have the slow pointer here and fast pointer also here. We move the slow pointer by one value, so we always say slow is equal to slow dot next, and we move the fast pointer by two values, so we always say fast is equal to fast dot, oh I can type here, fast dot next, right? So the slow pointer will always jump one position, but the fast pointer will jump two positions, right? Now because of this, the breaking condition will always be that we check if fast is not equal to null, so either this has not reached null or fast dot next is not equal to null, right? So that we don't move two steps if there is a null that exists. Okay, now let's go back. We'll say while fast is not equal to null and fast dot next is not equal to null. Okay, both of them need to have the value, though fast dot next can be null, that is allowed. Okay, so slow will move slow dot next, and fast will move fast is equal to fast dot next. Okay, now if there are loop if the cycle exists at one point in time, they'll align on the same node. So if slow is equal to fast, we can simply return true. Or if in this whole if the loop breaks because we reach the null in the end, we need to say return false. Okay, again just understand this, just to understand this condition. If there is no loop, right, if there is no loop, we have linked list something like this. We have 1 2 3 4 3 2 1 1 pointing to 2 2 pointing to 3 pointing to 4 4 pointing to null, and we have a fast pointer here, we have the slow pointer here. We check for that fast is not equal to null and fast dot next is not equal to null, because what would happen is slow will move by one step, so slow will move to 2, fast will move to fast, and fast 3. Again we'll check slow will move to next and fast will move to next and next, that is it will reach null. But let's say if there are 5 elements, 1 2 3 4, 5, and 5 is null. 4 is pointing to 5, 3 is pointing to 4, 2 is pointing to 3, 1 is pointing to 2. And we have fast pointer here, we have slow pointer here. Fast is jumping by 2 steps as we can see, and slow is jumping by 1 step. Slow moves to 2, fast moves to 3. Slow moves to 3, fast moves to 5. Slow moves to 4. Now fast will move to next dot next. But next is already null. How can we have next dot next value? That does not exist, right? That's why we always check that while fast is not equal to null and fast dot next is not equal to null. So in this case, when fast reaches from 1 to 3 to 5, we'll check for the next cycle that fast is not equal to null. Yes, fast is not equal to null. But fast dot next is also not equal to null. No, fast dot next is null, right? So the loop will break. Okay. Now, then we'll check if slow is equal to fast. We can return true. Otherwise, in the end, we'll return false. So let's run. Okay. Somewhere when we are printing the display, okay, system.out.println. Okay, let's run it for a neater version. Does list have a loop? True, the list has a loop. Okay. So this was the circular linked list, how we detect a loop in the circular linked list. That's all from this video. I know this has gone really big, but these are the code examples for singly linked list, doubly linked list, and circular linked list. And please let me remind that the linked list is the fundamental data structure for all the data structures. So please go through the part 1 very carefully, then come back to part 2 and please understand it. For anything else, please let me know in the comment section. In the end, please like, share and subscribe. Thank you.